There's even stuff that is beyond vitamins and minerals, things like peptides. People might have heard of BPC 157 or other peptides, which are small protein molecules of less than 50 amino acids that have amazing functions in the human body. There's probably nutritional factors in blood, in liver, in heart, in testicles that we don't even know about. We don't even name them. They're definitely not in the USDA database, so they don't show up on Chronometer or any of these other health trackers. And that's, I think, the limitations of nutrition is people will start and say, I'm going to put my diet into MyFitnessPal or Chronometer. And they'll say, look, I'm getting all these things and I'm deficient in these things. But a lot of these apps don't even have vitamin K2 on them. Like the USDA doesn't even include vitamin K2, which we know, as an example, is a critical form of vitamin K. There's K1 and K2, and I'll just illustrate this. K1 is phyloquinone. K2 is a series of compounds called menaquinones, with MK4 being the most bioactive, probably. Observational study called the Rotterdam study, and they looked at intakes of vitamin K2 and vitamin K1 in the population, and they divided the population up into 3 groups depending on how much vitamin K2 they got. We call this tertiles. So the lowest group, the middle group, and the top group. And I think the top group was around 35 micrograms of vitamin K2 a day. And this is observational, so we can't draw causative inference. But it was so clear that the group that had the most vitamin K2 had the lowest rates of heart disease and the lowest rates of aortic calcific aortic sclerosis, so calcification of the aortic valve. And vitamin K2 is really only found in animal foods. So what they're saying with this observational study, or the hypothesis that you can draw from that, is, wait a minute, everybody or that consume mainstream media believe that animal foods are bad for us. But here's a nutrient that's essentially only found in animal foods that is associated, again, it's not causative, but it's a real strong association for which the most compelling hypothesis by far is that this vitamin is essential for the movement of calcium in the human body. And if you don't have enough vitamin K2 from animal foods, you're going to develop more heart disease and more calcification of the aortic valve. Those things fly in the face of our modern sort of paradigm of human nutrition and what's good and what's bad. And so that's just the beginning of the iceberg. But the K2 is not even in the USDA database. And the end of that story is that vitamin K1 from plants, there's no association, meaning that no matter how much vitamin K1 people were getting, there was no decrease in cardiovascular disease and no decrease in calcific aortic sclerosis, suggesting that our body's not that good at converting K1 to K2. Well, that sounds like a really important nutrient to have in the USDA database, but people won't even know about that nutrient if they're just using Chronometer. So when I went to medical school, like 90% of my professors were obese, sickly, pale, not healthy, not friendly all the time. Physicians I worked with, right, on rotations, residents. I worked with very few individuals who were healthy. In medical school, so I went to the University of Arizona for my MD, and then I went to the University of Washington for residency. Great institutions, never was nutritional biochemistry talked about with regard to any disease. It's disease management with pharmaceuticals. That's what we do, which is, there's a place for that, but it's completely different than what I got interested in. The history of this is fascinating. There was no such thing as a seed oil before 1870. And then it was first used as a machine lubricant. So they would grind up seeds and use the oil as a machine lubricant. It wasn't really popularized for human consumption until 1910, 1911 with Crisco. They had this excess machine lubricant and they were thinking like, oh, let's use this for human consumption. This will be great. It doesn't spoil as well. It's cheaper. It's lighter. If you look at human health, and of course, 1910, 1900, 1870, 1890, not quite the same as we have now with medicine, but we had records, right? We pretty much knew what a heart attack was, and heart attacks were very rare. Diabetes, very rare. Obesity, very rare. There's photos from even 60 years ago, and we look at humans and they were much less fat than we are today. So there's a clear transition in the last 100 to 110 years. Seed oils really didn't exist before, let's just say late 1800s, and then introduced into the human supply chain early 1900s. Now, along with that, again, this is all correlation, so we have to be careful. We can only draw a hypothesis from this, which we must test, and we can go into all of the lines of evidence that make me very concerned about seed oils. With the introduction of seed oils from 1910, we see a steady rise in chronic illness. All of it tracks together, gradually increasing rates of obesity, gradually increasing rates of cancer, gradually increasing rates of heart disease, gradually increasing rates of diabetes. And the most significant data we have is probably in the last 50 years, and the trend has continued. But that trend goes all the way back to the early 1900s. Again, that was the beginning of the medical system and the American Heart Association and the American Medical Association beginning to vilify cholesterol, and then in connection with that, animal fats. back up again for a moment and we look at the health of the population early 1900s, pretty darn good. I mean, I don't think everybody had amazing diets, but for the most part, there wasn't any seed oil in 1900 in the American diet. People were eating exclusively tallow, which is rendered beef fat or lard. And the majority of pigs in 1900 were probably fed way better diets than they're fed today. The majority of pigs today get corn and soy. So we had animal fats, which were much probably better for humans. And they were essentially 100% of the human diet of fats was animal fat, maybe a little bit of olive oil, but not even a whole lot in 1900. And so you're looking at butter, tallow, and lard as the main fats in the human diet. And the rates of chronic illness were very low. Diabetes, very low. Heart attacks, very low. Cancer, much lower. So you're thinking, wait, how come nobody talks about that, right? Like, so again, it's a correlation. We see the introduction of seed oils in the last 100 years, especially in the last 50 years, we know things have gone down the toilet. So it's a very interesting history, and it's been marketed to us as originally a cheaper, better alternative. It doesn't spoil. It looks clean. It's white. Crisco's, is pure white. Margarine is pure white. They have to put pills in it to make it look the same color as butter, which has flavonoids in it from the grass that the cows are eating. And the darker the butter is, the more grass the cow's eating. So it began with that. Again, it's a machine lubricant that got sold to humans as a food. This is really an important thing for me in this work, that I want to help people understand from a medical perspective, what are the real problems? People that want to get healthy in general, they feel so overwhelmed by health information. They think, oh, I should avoid processed sugar, and I should avoid wheat, and I should avoid gluten, and now I should avoid seed oils, but they're in everything. These are the things that I think are most problematic for humans. The first one is seed oil. Minimize the amount of linoleic acid in your diet, and you will do better. The second is processed sugar, and I think that that's in contradistinction to sugar that is found in fruit or honey that is raw and organic. I think fructose performs very differently in humans, whether it's in a food matrix or whether it's been processed out of the food matrix. So that's a whole nother rabbit hole we can go down. And the third one is probably gluten. So if people eliminate those three things, I think their health will massively improve. But that is a big ask for people, because it means if you're going to cook potatoes, you got to use tallow. If you're going to cook vegetables, use tallow, use butter. But I think most people can do that with a little bit of choice. And you have to read the labels like you're doing. You have to avoid things like mayonnaise, which are definitely going to have seed oils. And the lower the linoleic acid is, the better. The flip side, I'll just mention briefly, and then we can go into it more in a second, is stearic acid. Again, that's an 18-carbon saturated fatty acid. All you need to know is that's in tallow. So if you do tallow, you're going to lower your linoleic acid. You're going to increase your stearic acid. Stearic acid's great. In human trials, they've done experiments where they made people vegan for 3 days. So they starved them of stearic acid. Stearic acid is yet another compound found only or exclusively or predominantly in animal foods that is essential for human physiology and optimal health, in my opinion, my strong belief. And so they made people vegan for 3 days, no stearic acid, and they look at their mitochondria, these little cellular powerhouses where all of this oxidative phosphorylation happens, where we actually take these macronutrients, where we take these carbohydrates and these protein molecules, and we run them through, we run electrons from them through the electron transport chain, and we get energy out of this ATP pump that spins in the inner mitochondrial membrane, et cetera, et cetera.
Mitochondria, the powerhouse in the cell where oxidative phosphorylation happens. Enzymes used to oxidize macronutrient molecules in the electron transport chain. 2, produce ATP, adenosine triphosphate, which provides energy for cell functioning, including burning body fat.
So you can look at the mitochondria of people who have no stearic acid, and they basically turn off. They stop burning fat. Mitochondria can also burn fat in a process called beta oxidation. And so all that stops when you don't have stearic acid. But then you give them back stearic acid. They give them, I think, a big dose of stearic acid, like 30 grams of stearic acid in a milkshake. And you start to see all of this fat burning turn back on for people, and the mitochondria fuse. You can see it in the study. The study's in one of the Nature journals, a very preeminent journal. I think that weight loss for people could be distilled down to this simple idea that if you lower linoleic acid as much as possible and you increase stearic acid, I'm so certain you're going to lose weight. You're going to lose weight because your mitochondria are going to turn on in your cells. You're going to start burning fat, and this linoleic acid and all these problematic things associated with it will be minimized. That's the formula: lower linoleic acid, more stearic acid.